Alright, here is another example of doing finding antiderivatives using the method of partial fractions. In this one we're looking at x minus 2 or x squared minus 6x plus 3 all divided by the quantity x minus 2 cubed. So instead of having distinct factors in the denominator, we now have a single factor, but it's repeated 3 times. So you've got an x minus 2 times an x minus 2 times an x minus 2. The way we want to break this out so that we get the proper number of partial fractions and makes everything work out so we can find values is to do an a over x minus 2 plus b over x minus 2 squared plus c over x minus 2 cubed. So we're going to get one piece for each factor down here. You gotta do the first, second, and third powers because it's the third power down there. All right, and like before, what we're going to start by doing is getting a common denominator. And so to make the denominators the same, in this first piece, I'm going to have to multiply by an x minus 2 squared on top and bottom, and then an x minus 2 to the first power, and that will make all the denominators x minus 2 to the third power all the way across. And once the denominators are the same, then the numerator has to be the same if I want these fractions to be the same for all values of x. So I've got 2x squared plus 6x plus 3 equals a times the quantity x minus 2 squared plus b times the quantity x minus 2 plus c. And I want these to be equal for every single value of x. So rather than equating the coefficients like I did last time, I want these to be true for every single value of x. So what I can do is you can pick values of x and see what the result is. And a really nice one to use, particularly in this case, is to say, well, what happens if x is equal to 2? If x equals 2, the left side will become 2 squared minus 6 times 2 plus 3. The right side will become a times 0 squared plus b times 0 plus c. So I can jump to what that c value should be right away, and it should be 4 minus 12 plus 3, so negative 5. So I get c, this should be negative 5. Get that right away. So you can just pick a value for x, and usually picking the value that's one of your factors up here makes this super easy to jump into one of the values right away. So I get c is equal to 5. Let's pick another nice easy value to do. Let's do x equals 0, just because 0 is an easy number to plug in. If x equals 0, the left-hand side of this, the x squared minus 6x plus 3, will just simplify to 3. The right-hand side will have a times negative 2 squared plus b times negative 2 plus c, but I already know c is negative 5. So I'm going to plug a negative 5 in there for c. Let's see, does that help us out anyway? Well, no, it gets us to a nice equation. 3 is equal to 4a minus 2b minus 5. We're moving the 5 to the other side. 8 is equal to 4a minus 2b. All right, and then if I let x equal 1, it's usually a pretty nice number to put in. So in the, I kind of lost it here a little bit, x squared plus minus 6x plus 3, I would get, if x is equal to 1, I'm going to get 1 minus 6 plus 3, and that's going to equal a times negative 1 squared plus b times negative 1 plus c, which I already know is negative 5. And so then that's going to give me equation negative 2 is equal to a minus b minus 5. So a minus b is equal to 3. And so I can pair that a minus b equals 3 equation up here with the 4a plus 2b equation. I'll get that a is equal to 3 plus b. So let's go and substitute in for a up there. 8 is equal to 4 times 3 plus b minus 2b. So 8 is equal to 12 plus 4b minus 2b. So 8 is equal to 12 plus 2b. And if you subtract 12 from both sides, a little more space there, thank you. I'll get negative 4 is equal to 2b, so b is equal to negative 2. If b is equal to negative 2, I know that a is equal to 3 plus b, so a is equal to negative 1. Positive 1. 3 plus negative 2 is positive 1. So that means that the integral I'm trying to find, remember we're trying to do an integral, way back up there was x squared excuse me, minus 6x plus 3 over x minus 2 quantity cubed is going to be equal to the integral of 1 over x minus 2. That was just x minus 2. Going back, check what I had for a. Plus b is negative 2 over x minus 2 squared. And c was negative 5 over x minus 2 cubed dx. And just for fun, let's do this one. Let's go ahead and make the actual substitution. That's pretty easy to do with substitution. Make u is equal to an x minus 2, and du is equal to dx. So my integral becomes 1 over u, or u to the minus 1 power, plus negative 2u to the minus 2 power, plus negative 5u to the minus 3 power, du. And if you take your antiderivative, the antiderivative of u to the minus 1, that's the natural log of u. I'm going to add 1 to the exponent, divide by the new exponent. So negative 2 plus 1 is negative 1. Minus 5u to the negative 2 over negative 2. And then plus c at the end there. So I'll get the natural log of x minus 2 plus 1 over x minus 2 plus 5 halves, well 5 over 2 times x minus 2 squared plus c. And that will be our antiderivative.